We live in a world that is becoming interconnected. Imagine a tool that connects all your data points so you can visualize in real time, seeing the impact of proposed changes, avoiding costly mistakes, extending your model to design and operational uses. Our vision is to become the leading process digital twin solution for improving the design and operation of complex systems.
Hi, my name is Joyce Wiener. I am a data scientist and principal engineer at Intel Corporation. And today I'll be talking about why AI and data science projects fail and how you can avoid project pitfalls. To get started, I'll share my screen. All right. So I got interested in this particular topic because I heard the following statistic, that the failure rate for AI and data science projects or big data projects was 87%. 87%, that's a huge amount. And by failure, what they mean in this case is that the project did not make it all the way to deployment. So there was a lot of work and effort put into something potentially that never got to the finish line. Now this is data that was originally published in VentureBeat, and when it was first published, it was only 85%. And then Gartner went back and re-looked at the data about a year ago in the summer of 2019 and discovered that the rate is actually now 87%. So then I started thinking about why this could be. So why? Why would there be such a high failure rate? And I've come up with 5 possibilities for why this would be the case. And I'm sure you have maybe other thoughts, and I'd be interested in hearing those during the Q&A session. So my 5 possibilities and the 5 things that I'll address and how to avoid in this talk are: 1, the scope was too big. If you bite off more than you can chew, then it becomes difficult to finish the project. And this is something that my Lean Six Sigma mentors would call trying to boil the ocean. The second one is scope creep. In other words, I started off with something that was doable, but as we went, it got bigger and bigger and bigger and became unable to be finished. Third, I couldn't explain the model. So as a data scientist, you develop something, you feel very comfortable with it, you show it to management, and they're like, it's a black box. Why is it choosing this versus that? If you're using a neural net, you can't really explain the why. And maybe they didn't become comfortable with this approach and therefore cannot deploy the model in production. Or the model was too complex and it just became unwieldy. It took too long to train, or too much data is required in order for it to be accurate. And so then you don't get to deploy that model. And then finally, and the most critical of these, is that you end up solving the wrong problem. So you've done a lot of work on the wrong thing. And that thing isn't really what's necessary, so it doesn't get deployed. So to avoid these 5 pitfalls, it's really about going slow to go fast. Doing some work up front will prepare you to get to the finish line. And I really learned this by doing something called autocross, which, if you see it for the first time, is a little strange looking. It's a bunch of car enthusiasts that get together in an empty parking lot with a bunch of traffic cones and outline a race course with one car at a time. It is timed. And the reason you go slow to go fast is really it's about handling and being able to maneuver around tight turns without hitting any cones, because you get a timing penalty for hitting cones. So being careful, going slow, actually gets you really good times in autocross. So going slow to go fast was a lesson I learned there, and can be applied in getting your data science project to production. So avoiding the pitfalls by going slow to go fast. Starting up front, asking the questions. Getting alignment up front and having conversation with your users and the end users of the model will help make sure that what you build is going to meet their needs, solve the right problem, and get deployed. Also, keeping it simple. Again, because that helps with explainability, but also because it helps with the scope. If I have a simple model that only requires a few inputs, it's much easier to have that go to deployment than a complex model that requires lots and lots of data. Or if I have a model that is easy and simple to train, I'll be able to maintain it more easily in the long term, and then it will be more easily put into production. And then finally, having that conversation, and having it as a continuous conversation, but mostly up front, and then as you progress through the steps, and we'll talk about the steps in just a bit. Having that conversation with the end user of the model will help set up everything so that they feel comfortable with it and that it will be effectively deployed. So one key question to ask is, will you solve the right problem? And again, going slow to go fast helps with this. Now, this came to light from research that was done by another principal engineer within Intel in our manufacturing side, who looked at technical problem-solving teams and whether or not they were able to come to a conclusion, get to root cause for that particular technical problem. And you can see the number one cause of not getting to a solution quickly was we made conclusions without data. We rushed ahead. We didn't go slow. Number two is we solved the wrong problem. So if you start off with the wrong problem statement, then you're not going to be able to get to the solution as fast. You'll have to revise your problem statement and make sure that you solve the right problem. So doing that work up front will help with these problems. Now, these are the phases of a data science or AI project. And one challenge for data scientists is that the fun part is the middle one, the modeling of the data. So there's a bunch of steps you have to do to get there, and then there's a bunch of steps you probably should do after you're done. But really, it's very, very tempting to just rush ahead and get into modeling the data. Clean the data as minimally as possible so that you can model it and then, have fun. And I caution you to take your time with these steps. And the rest of my talk, I'll give you tools and methodologies to help avoid those project pitfalls, enable you to slow things down just a bit, and set yourself up so that you can get all the way through to the very final step and actually deploy your model into production. So let's get into these tools. So looking at that first step of defining the project objectives, this is key because this is a lot of that upfront work. that sets the project up and makes sure that you're working on the correct problem. And there are two tools that I'd like to share with you for this particular phase. And these tools come out of Lean Six Sigma, so you may already be familiar with them. And they are, one, a project charter, and two, something that's called a SIPOC, which is an acronym for Supplier Inputs, Process, Outputs, and Customer. And together, these enable you to scope your project in advance and help have that communication, and their methods to have that conversation with your end user, your stakeholders, and with management. That way you can ensure that you have that upfront alignment before you get started. So we'll walk through each one individually. Let's start with the project charter. So the project charter is a document, it's a living document where you can go back and revise throughout the life cycle of the project. And it addresses what the problem is that you're trying to solve. So then you have that documented. And again, you can always go back and revise it as necessary, but it's documented somewhere and you can check to make sure that you're solving the correct problem. You can show it to people. It also captures how will you know that you've solved it. And this was really key to helping prevent scope creep, because you have a definition of done and you know when you can stop. It also covers what's in and out of scope. This prevents boiling the ocean. And so you can establish the boundaries for where your project starts and stops, and what you're going to cover and what you're not going to cover. And that way you don't have that tendency that you have when you're modeling something, oh, I can just add these features and I can get this other prediction as well, and it'll be so great, and it gets bigger and bigger and bigger and you never finish. So it's key, and it's very helpful in that it gives you that framework, and then you can go back and revisit it as you're going through the project, and you can always revise it. So it's not a one and done type document, it is a living document throughout the project. It also gives you an opportunity to document your business benefit. And this is key when you're having conversations with management, because then you can explain why they're funding this particular project and what it'll get them. And we'll talk more about how to measure this and be able to put some into dollars and cents so that you can compare projects, which is helpful if you need to prioritize projects against each other. You also document in your project charter who's involved in the project, who your stakeholders are, and key, who's the final decision maker for the project. And all of this work up front, again, enables you really to have those conversations and then get alignment, make sure that you have buy-in, and then you're able to move forward. So let's talk a little bit more about business benefits and business benefits by various project types. So I have 5 examples of different project types that I've participated in. There may be more, but for the ones that I've done, there are typically things like data analysis type projects where you're looking for signals or you're attempting to determine a root cause, or you're identifying a problem through data analysis. There's also automation type projects where you're combining data from multiple sources, developing a dashboard or some report so that people can make decisions more quickly. There are standards and business processes that can be developed that will help do things like excursion prevention or quality improvements. And again, my background is in manufacturing, so some of my examples are very manufacturing oriented, and this is things like process control systems and other things like that. You can also deliver new insights. So you can identify something through models that enables engineers to learn something new. And I had this experience in showing a number of engineers a dashboard that I created. And in that dashboard, it was the classic, right? I took data from multiple sources and combined it and visualized it in a way that they would be able to get insights. And in the meeting where I was demoing the dashboard to the customer, one of the engineers had an immediate aha out of it and left the room so that he could call the factory floor and take care of an issue that the dashboard was able to show him. So that can help. Also, that can provide, that type of insight can also improve the quality of decision making. And lastly, you can always have an increase in the organization's data science capability out of a project. So you may be advancing algorithms, or you may just be providing a resource that allows other members of the organization to learn more about data science and increase their capability. So these are types of projects and the types of business benefits that can be delivered. And now I'll show you a table of various business benefits and conversion factors. Now this is key because it's helpful to put everything into a single metric, typically dollars, so that you can compare different projects against each other. And it's hard if you just have the initial metric, because time saved versus, part consumption reduction. The part consumption reduction is clearly dollars, and so that might take priority unless you can map the time savings also into dollars. And then you might be surprised by how much a benefit it could be. So obviously, if you're just doing a straight up dollar savings, that's very easy. If you're doing something like time to market improvements, then, in terms of, weeks pulled in, you can monetize that. Time to decision. If you're building dashboards and being able to facilitate making a decision, it takes less time because people don't have to go source data from multiple places or view multiple web pages, and you can consolidate it for them into one place. That's a significant, or that can be a significant time savings, and so that can be monetized. But there's also other types of waste that can be monetized, and this is classic lean, Tim Wood, and again, from factory perspectives, this is transportation, movement of product, and so on. But you can also map these into office type work. And when we're talking about transportation in this case, then instead of movement of a product, you're talking about movement of information. Inventory, how many email unread are in your inbox? That's inventory. So if you have some sort of transactional activity in an office environment, you can usually map exactly to these types of waste. And then another one I'd like to highlight here is decision quality. So decision quality, your quality of a decision, is not necessarily that it will always produce the outcome that is desired. It's about whether or not multiple alternatives were considered, that data was used to determine which alternative was the best, and that logical reasoning was applied. And so there's a whole frame for decision quality as well, and you can see here the elements of it. Again, were there alternatives considered? Was information used? Data was actually used to differentiate between those alternatives? Was the decision itself rigorous and logical and was there commitment to actually take action? So this is about the business benefit, then that goes back into that project charter. So then you have upfront understanding of what you'll deliver. And in addition to your definition of done, then you're set up to have a project that gets to the endpoint and is deployed. Another thing to keep in mind when you're monetizing the benefits of your project is if you free up people's time because they're not having to do so much work in order to get the data that they need to make a decision, they then go on to do something else. And your project is enabling that, so you should monetize that as well. All right, so that's the project charter. Let's now move into the SIPOC, which again is the supplier input process output customer. It's a mapping framework and it really helps with scoping. And so let's talk about how that works. In the center of your SIPOC is your process, and that's where you start. So this is, what is it that you're going to be modeling? And, you know, where is it starting and where does it end? And then you talk about or think about what comes out of the model and what does the customer need? So how often will I be running the inference on this model? And how accurate do I need that to be? Am I making a go, no-go decision, or do I need an actual value? So thinking about what the customer needs, then, you know, what output is needed from the model helps then to determine what needs to go into the model in order to have that output generated. So again, it's very, very helpful for scoping. So after you think about what comes out and who needs it, then you work on the input side and what's necessary to go into the model in order to produce that output. And what data do you need? How good a quality is necessary for that data? How often does the data need to be input, etc. And you can define all of that. So again, in this defining phase, both the charter and the SIPOC are very, very helpful for ensuring that you've scoped things, but also to drive those conversations up front so that you can ensure that everybody's in alignment on what you're going to be doing. The next phase that I want to talk about is the modeling data phase. And again, this is the exciting phase, and this is where it's tempting to use the latest and greatest model or something that you've never used before and really get into the data science and have a lot of fun with it. And again, I would caution you to just keep things simple. So that's the key way to avoid project pitfalls in this phase, is to keep it simple and also leverage explainability. So keeping it simple, and I mean really keeping it simple, like, is there a physical model that or equation that you can apply that works to do the prediction that you need? Then use that. If there's already an equation for it, you don't need to do anything fancier than that. There's an equation, it works, it's beautiful. And in my case, this was the case that when I was working in lithography and doing process control, we had equations that explained, you know, physical equations that explained what was going on. And if we were trying to control our critical dimensions, if I knew the input parameters, I could predict the output and compare to the actuals and then be able to adjust things in a feed-forward, feedback way. And that was very effective. So very simple physical model. If you cannot have a physical model, can you do it with machine learning? Again, because it can be explained and it's easier for someone to understand what's going on. And then use caution with neural nets. So this is a paper that was describing explainability of a neural net's decision making. So this net was trained to differentiate between a husky dog and a wolf. And unintentionally, the training data set had some bias to it. And when the researchers investigated, and P.S., the model had very good accuracy of determining husky versus wolf. But when they dug into what was going on, what they discovered was the model was actually a very good model for finding snow in photos. And as it turned out, there was a very high correlation between the training data set of huskies and having snow in the background. So if your image of a dog had snow, it was a husky. And if it didn't, it was a wolf. So again, be very cautious with neural nets. Beware of unintentional bias in your training data sets. And if you could do it with machine learning instead, do that. If you can do it with a physical model instead, do that. And then leverage explainability. So then this is a key, again, to have that conversation up front and know, does your end user need to understand why the model made the choice it made? Or is it okay just to have the model say yes, no? And I should say, when it comes to neural nets, by all means, for image processing, they can be the best for that. So use the right tool also as part of it. So is it important to your customer to be able to understand how your model is deciding? And if so, take that into account when you choose what model you're going to be using. And then the last step is the deployment step. Implementing, documenting, and maintaining your model. And this one, it's really about, as Stephen Covey would say, beginning with the end in mind. So thinking ahead at the start of your project to this end state will make it much easier to get to the final deployment and beat those odds and not be one of those 87% when you're actually thinking about it at the very, very beginning of your project. So how are you going to deliver your model into production? If you're going to be having to build an entire web page in order to deploy your model, that's a much heavier lift than if it can be an API call into an existing software package or an Excel macro. So plan for deployment up front. How is it going to be used? How is it going to work? And how does your user want to engage with the model? So how will you deploy your model? And again, keeping it simple is good. So if you can do it in a simple way or incorporate it into an existing system, it's much more likely that your model will be deployed than if you're trying to do something else. Again, when I was in manufacturing, we had shop floor control computers for every piece of equipment in our factory. And the best way to deploy models for process control was to put them on that shop floor control computer. It was already there. All of our manufacturing technicians were accustomed to using it, and so we could just deploy models straight there. That made it very easy. And then you have to think about things like who will own and maintain that model. So in our case of manufacturing, we knew that things would change on about every 6 months or so. So I knew that there was going to have to be a maintenance phase, possible retraining of the model on a 6-month cadence. What is it for your situation? How frequently do you need to retrain your model? Again, a great thing to be thinking about up front, because if it takes a lot of data and a long time to train my model, I'm not going to want to do that on a monthly basis. I might be okay with doing that on a 6-month basis, and probably okay with doing it on a yearly basis. So what type of model I select will depend on things like that. How easy is it to maintain long term? And how will you know if it stops working? There's nothing worse than having a dashboard that people are using for decisions that hasn't been updated in the last 2 weeks, and nobody knows. So my best known method for that is to always have a programmatically updated date timestamp at the top of any of my dashboards. That way, people can look at the timestamp and say, wait, that was yesterday, and know to call and say, hey, dashboard's not updating. So that's a key thing. How does that work for your model? How do you know that it's properly performing its inference when it's deployed? And when will you update it? What are the criteria that are going to trigger an update? Is it going to be a time-based thing, like I really should, just retrain on some cadence and then compare and ensure that things are predicting accurately? Or, using my test data, how will you ensure that things are working properly, and how do you know when to trigger an update? So to avoid project pitfalls, it's really about going slow to go fast. Having a lot of work up front will make sure that your project gets all the way to completion. So ask the questions, have that conversation, getting alignment using a project charter or other tool to ensure that you've captured things down and also documented it. Keeping things simple, using a physical model of what exists so that you can leverage explainability, again, if that's important to your customer. And then having those conversations. And finally, I should underscore having that documentation about what it is that you've done in your project, how it was done, how it's been maintained, who owns the model. All of that is very important. One of my favorite quotes is, documentation is a gift you give your future self. So with that, I'll leave you with one last quote. And this one is from Einstein. And it just underscores that benefit of the upfront work and going slow to go fast. And now we'll open it up with one last thing. So the number one tip, my take home for you all, is, are you having the right conversations?